Okay, so this is our cone calorimeter. I believe the test standard for this one is ASTM E1354, and there's probably some other standards that use this, but I think 1354 is the ASTM standard. So basically the whole point of this apparatus is to, on a small scale, measure the heat release potential of a material. I don't know the actual size of the material that goes in this apparatus. It basically sits here on this platform, and it's subjected to a radiant heat exposure from this cylindrical, conical shaped heating element. I believe there's 25 kilowatt, 50 kilowatt, and 100 kilowatt exposures where you can kind of get different profiles on the material and how it performs at different heat impingements. So what you get is the sample starts to burn. One of the metrics that you're measuring is the time to ignition of a material. The gaseous products of combustion are pulled in through this hood right here, where we have instrumentation in line. We have a gas analyzer analyzing the oxygen content, the CO2, and the carbon monoxide content of the gas. And with those numbers, you can determine the heat release rate of the material. The sample on this platform is actually also sitting on a load cell, so we can measure the mass loss rate while you're getting this heat release rate information, and you can come up with effective heats of combustion per unit mass for the materials. You can just come up with the instantaneous heat release rate, what its peak heat release rate is, total heat release rate, smoke production rate. So you can get a real good characterization of a material from a very small scale sample, and just something in the context of the other tests that I've spoken about. The large scale tests and what was the one I just showed you, the radiant panel, those are all tests of assemblies. Those are combinations of products. It's important to distinguish that from this test, where this is a test of a material. You put one material in here to characterize how that material behaves. You wouldn't put a combination of materials in here, at least by any test standard you wouldn't. Where those are all assembly-based simulations. So that's a main difference between this small guy and those large-scale fire resistance tests. Anything I missed on this apparatus?
No, I think that's it.
Okay.
And just point out the scale.
Oh, well, I don't actually know.
Or the pieces.
This is the platform where it's sitting on. You have your heating element right here. The load cell or the scale is down here at the bottom. Again, I don't manage this test, so I know the basics of it. I don't know the actual apparatus all too well.
Okay, no, that's good. Okay, thanks, Dave.
Absolutely, my pleasure.